Good day, everyone. I'm BSK3103. I'll be presenting question 1. Carbon, which has 66.6%, hydrogen has 11.1%, oxygen has 22.3%. Assuming a 100-gram sample, carbon will be 5.55 mole, hydrogen 11.1 mole, and oxygen 1.39 mole. Next, we divide each mole value by the smallest. Carbon is 4, hydrogen is 8, and oxygen is 1. So, the empirical formula of the compound is C4H8O. Moving on to the UV-Vis spectroscopy part, the compound shows an absorption band at 275 nanometer, with a molar absorptivity of 17. This low intensity indicates a non-conjugated chromophore. The absorption at 275 nanometers and low Emax are characteristic of an N to P transition, which is typical for carbonyl-containing compounds. This transition involves the excitation of a non-bonding electron to an antibonding p orbital. I would like to pass it to my next group member. Thank you.
Hello everyone, my name is Gayatri Uthayakumar. Today I'll continue presenting question 1, which is how we identified an unknown organic compound using FTIR and proton NMR spectroscopy. First, from the FTIR spectrum, we observed 3 key peaks. A peak around 2941-2957 cm2-1, which indicates the presence of CH stretching, suggesting alkyl groups. Next, a strong peak at 1715 cm2-1, which clearly confirms the presence of a C double bond O stretching, indicating a carbonyl group such as a ketone. Then a peak at 1460 cm1, which shows CH2 bending, further supporting the presence of alkyl chains. From this FTIR data, we predicted the compound could be a ketone with alkyl groups. Next, we analyzed the proton NMR data. There are 3 signals. Firstly, 2.48 ppm, integration of 2, a quartet. This corresponds to a CH2 group adjacent to a CH3 group. Then, 2.12 ppm with integration of 3 and a singlet, where it assigned to the COCH3 group, meaning a methyl group next to a carbonyl. Lastly, 1.07 ppm with integration of 3 and a triplet, where it assigned to a CH3 group coupled with CH2, indicating an ethyl group. By putting all this together, we see that the compound has 4 carbon atoms, a ketone group at carbon 2, and ethyl and methyl groups on each side. Based on both FTIR and also NMR data, we conclude the structure is butane 2,1. That's all from me. Thank you.
Hi everyone, my name is Kirtiswaran Murali. I'll now present for question 2. A peak is observed at 268 nanometers in the UV-Vis spectrum, which is a P2P star transition found in aromatic systems. This absorption occurs at a slightly higher wavelength than that of unsubstituted benzene, indicating the presence of electron-donating substituents, such as methyl groups. In IR spectrum, the absorptions in the range of 3067 to 2907 were consistent with CH stretching vibrations of both aromatic and aliphatic hydrogens. Additional peaks at 1608 and 1473 inverse centimeters correspond to aromatic C double bond C stretching vibrations, which are characteristic of benzene derivatives.
Hello everyone, my name is Yapyu Jen. I will now explain how to predict the molecular structure of a compound using NMR spectroscopy and molecular mass data. Let's begin with the NMR spectrum. A peak appears at 2.26 ppm with an integration of 9 and a singlet multiplicity. This peak corresponds to hydrogen atoms in methyl groups that are located near an electronegative atom or an electron withdrawing group. The integration value of 9 indicates the presence of 3 equivalent CH3 groups. The singlet pattern suggests that each methyl group is bonded to a carbon atom that has no adjacent hydrogen atoms or is directly attached to a benzene ring. Therefore, this peak supports the presence of 3 methyl groups in the compound. Another peak is observed at 6.79 ppm with an integration of 3 and also appears as a singlet. This chemical shift is characteristic of aromatic protons, specifically those attached to a benzene ring. The integration of 3 indicates the presence of 3 aromatic hydrogen atoms, and the singlet pattern supports that these hydrogens are bonded to a benzene ring. This supports the presence of benzene ring in the compound. Based on the NMR data, we can predict that the compound is 1,355 trimethylbenzene, which consists of 3 methyl groups attached to a benzene ring. Let's now consider the molecular mass. Trimethylbenzene contains 9 carbon atoms and 12 hydrogen atoms. Given that the atomic mass of carbon is 12 gram per mole and hydrogen is 1 gram per mole, the molecular mass of the compound is 120 gram per mole, which matches the molecular mass provided. This further confirms the structure of the compound. In conclusion, we can predict that the molecular structure of the compound is 1,355 trimethylbenzene. We've now come to the end of this video. Thank you for your attention.